This is a spec sheet that I made about the VDP or the PPU for the hack. It has a massive 1 megabyte of VRAM. It has 256 color palette, just like the Vera. And I want the basic default palette based on OKLab because it's the cool new palette that will give you like nice and even colors. And it will have 8x8 or 6x16 tiles, but it will have 4 planes, double the amount of the Vera, because my machine need to have better graphics. And I designed a few like quirks to make it stand out. One of those is like sprite anchoring. You can anchor a sprite to the top left, top right, bottom left, or bottom right of the screen so that if the screen is connected to different types of monitors, for example, an old CRT or an LCD or anything, it's like you can use sprite to create some UI that will kind of follow the screen and not end up being in awkward places. There will be tile flipping. There's horizontal, horizontal, vertical, or horizontal, vertical, and rotate 90 degrees. And you have these options to choose from for your background. And there's a trade-off because if you disable the last used features like rotate 90 degrees, you get one more bit to address more tiles. I think this is a really good addition and would give more options to programmers. And the sprite will have 8 or 16 colors, but I don't want to do bit planes and I want to do chunky colors. That means like 8 colors doesn't work because there's one wasted bit. So I invented this called Sprite EHB. And if you don't know what EHB is, it's for enhanced half brightness. It's something I borrowed from Amiga. Basically, I use this one extra bit of bitmap to create a half brightness effect for the color. And this will allow the programmer to kind of break the 256 color limit, but not actually going into something like 512 colors because I think that would be just too much colors for a 8-bit looking system. If there are 8 colors and there's a half bright bit, then there should be like 2 transparent colors because you can only have 7 valid colors. So I created this auto shadow feature. Basically, the half bright transparent color will be a shadow effect. It will take the color that's behind it and halve it. And this gives your sprites pretty nice shadows. And I want to add more, like the windowing effect on the SNES and color math. And maybe vertical scrolling, like vertical split screen scrolling, like those in SNES mode 2 or something. Now I want to do HDMA or copper effect, something that can be synchronized to the horizontal sync. And now, after reading that FX feature for the Vera chip, now I need to add some math engine or proper mode 7 to rival that. Because if I don't do that, Hack would not sell the original Hack design called for V9958. That's the VDP for MSX2. It's nice, it's powerful. It is a native 16-color bitmap engine, and it will do hardware, I think, line and hardware sprite, like hardware draw and sprite blittering. And originally I decided to pair it with a 20 MHz Z80 because that's the highest clock speed I can get. But as soon as I wrote some MSX2 programs, I realized that it won't work. On the MSX2, the CPU is 3.58 MHz, and it is already bottlenecked. It is already bottlenecked by the VDP because the actual bottleneck is the bus between the CPU and VRAM. The CPU have to write to a register in the VDP to transfer it to the VRAM, and it's not like the Vera where the CPU can basically just bang all the bytes to Vera, and Vera will deal with it. On the VDP, you have to wait for the VDP to respond and actually write that byte into VRAM before your CPU can proceed. This problem will be even greater when the blitter is in use, and it will be even greater when I clock my CPU at 20 MHz. Even with a CPU at 20 MHz that may be able to do some really cool polygon 3D effect on the CPU side, the actual graphics result will not be a lot better than an MSX2. And that's bad. It's like when I started programming on MSX2, I immediately realized why Hideo Kojima did Metal Gear on the MSX2. MSX2 graphics kind of lacks motion. I mean, with V9958, you do have like horizontal and vertical scrolling, but you don't have more fancier effects like the tile animation of the NES, because it's not a tile engine. If you want to animate the tiles, you will actually need to blitter all the animated tiles on the screen. And because the V9958 uses regular DRAM, it just did not have the bandwidth to do that efficiently enough. That's why I started this. Borrowing pages from the SNES, borrowing pages from the Amiga to create an engine powerful enough that will sell the hack. And that's not the hack's fault, because the feature of the hack is that it has a protected mode. For those entry programmers and people who want to grasp the idea of computing, I put hack as one step ahead of the Commander X16. Is that when you finish about the 6502 and all the real mode stuff, the hack will teach you how modern computers schedule the tasks and do multitasking and do that, and it will teach you that, and it will do it in a discrete and simple way with an 8-bit CPU. That's the promise of the hack. That's the idea behind the hack. It's not about graphics, it's not about sound. It's about it being able to run programs from the MSX, from the ZX Spectrum to a lesser extent, because it uses memory mapped graphics. But from the Amstrad, it will run programs from the MTS 512. It will run programs from the Sega SG 1000, I think. It will run program for the ColecoVision, Coleco Adam. It will run program for the PC 6000. It will run program from the PC 8801. It will run CPM programs and all of those stuffs. It will do all of them. But that's my mistake of building a computer with such a feature set. Because that feature set don't sell a computer. If you want a computer that plays all of those stuff, you use a PC, you use a Raspberry Pi. This is a Raspberry Pi 3. You can use this Raspberry Pi 5, and it will run much better than the hack. It will have much greater compatibility. It will have compatibility that the hack can never ever dream of, because the hack, although it's like real CPU, it has got to emulate those I/O. It has got to catch all the I/O instructions and turn them into a lengthy sequence of driver calls to make sure that the correct write goes to the correct device. This does not need any of that. It can just emulate the entire hardware. And when you are done with one system, you can just load another emulator because you have the power. The advantage of the hack, the feature of the hack, is just too nerdy, too academic. It's built for academic interest. It's a proof of concept that such things will work, but it will not sell. I know it won't. That's what frustrates me.